All right, this is a video that goes over numbers 47 to 49, and this is a graph of a runner, and the x-axis here is the time in seconds that he's been running, and the speed that he's going is your y-axis here. And this is on page 466 in the book. I would look at the figure in the book, but I will use this on the video just to refer to it so that I can point out where they're at on the graph when they're asking the questions if you're having trouble. If you read this, it says the slope of a line is the same at every point. But so when we have a line, the slope's the same everywhere. That's what makes a line. But we don't have a line here, do we? We have a figure that looks like it might start out being sort of a line, and then all of a sudden it does all kinds of things. It's not a line. The curve below shows the speed of an athlete running the 100-meter dash with respect to time. So he's going to really tear out of the gate and go accelerate really quickly. He's going to reach his peak speed at about, between 2 and 3 seconds. If you look at the book, it's easier to see than my diagram. And then he kind of levels out on his speed, doesn't he? And then at the very end, he goes toward the finish line, which is the very last point there at 11 seconds, and he kind of speeds up again a little bit maybe he's trying to beat somebody across the finish line. You could kind of see this in the graph. So the question 47 says, the slope of the curve is positive from 8 seconds, so about from here to the finish, and it's positive because it's going up, okay? Where else does it appear to be positive? So they're telling you this is positive, and look, it's going up. Where else on the graph does it look like it's going to be positive? Well, if you look, isn't it going up here, and it kind of keeps going up here, and I would say somewhere between 0 maybe, and let's say about 2.5 seconds. It's kind of hard to see exactly what that point might be. But that red piece that I highlighted there, it's going up. And in algebra, we say that's increasing when it goes up, okay? So at that point, what's happening is he's speeding up. He's accelerating, picking up the pace, right? Trying to get a good start there. And then at the end, he's trying to finish well also. Now, 48 says, over what interval does it appear to be 0? All right. His speed, the slope, not the speed. We're not talking about that he stopped and his speed is 0. They're talking about where does the slope of the curve look like it's 0. That would be where does the graph flatten out. A horizontal line has a slope of 0. Doesn't it kind of look like there's a little piece of this graph right here, maybe from here to here, where it's kind of flattened out? That is like a horizontal line, so it has a slope of 0. So that looks to me like it's between about 5 and 8 seconds. I could write between 5 and 8 seconds, or I could write the speed is between 5 and 8. I could do that, right? I could describe it that way, and that's the way we normally do it in math, and usually speed would probably be a variable like y or something like that. Okay, so you could have written between 5 and 8, but this is kind of the preferred way to write it. I thought I would just do one writing it out just so we, have a way to kind of compare words and notation. Okay, so 49, where does it appear to be negative? Basically, if you have a negative slope, the slope, or the graph, if you want to say the graph, maybe it would make more sense to you, it would be going down. Where does it look like he's going down on the graph? Well, let me use a color like green to show that. Doesn't it look like he hits his peak speed up here at the top, and then it starts going down here where I put the green, doesn't it? To me, that looks like it's between 2.5, and since the speed is on the y-axis, I would put a y there. I could write it the way I did 47 or 48, but I'm going to, again, just try to help you see how you get the notation you usually see in a math book. It appears to be negative between maybe 2.5 and 5, I'm going to guess, is what it looks like. My graph doesn't look, I would look at the book because it has the lines. I was just trying to sketch something in general. But look at your book and see that that's where it's going down on the graph. This is important to know. This kind of stuff, oh man, it could show up on SATs, your achievement tests that you take, all kinds of places. All right, so what is happening to the runner's speed when the slope of the curve is negative? We said the slope of the negative was that green area that I highlighted on the graph. Well, that's when he is slowing down. He's still running, isn't he? He's not going backwards, so what could that mean? It means his speed is decreasing. He's slowing down a little bit. He sprinted, got up to his maximum speed, got a little tired. He's slowing down now. Maybe he's pacing himself when, I don't know what he's thinking, but 51 says, what's happening to the runner's speed when the slope of the curve is 0? All right, when the slope of the curve was 0, this was this blue area that I highlighted here on my graph, and it's where the flat area is. That's when he's maintaining a constant speed. Oops, that's not the way you spell maintaining. Maintaining a constant speed. He has kind of hit his stride. He's running. He's not speeding up or slowing down. He's just going at a constant speed. I still maintain. Here we go. A constant speed. It's a good thing I'm not teaching English. Okay, so that gets you through that little section there if you're having trouble with it.